Today's lesson is on borrowing money. Good financial habits such as creating a budget and saving for the future are key to staying financially healthy. However, even with the best budgeting skills, sometimes we must borrow money in order to make larger purchases, such as a car or house, or bridge the gap when emergencies arise. A grace period is a period of time in which no interest accrues on a debt. The minimum payment is the minimum payment amount the lender requires you to pay each month. This amount is typically equal to a percentage of the total balance, and it's usually mostly interest, especially on credit cards. The number of fixed payments are required to pay off a credit card debt is calculated with this formula. And you can see there's logs in this formula. Now, we might talk about what logs are and a little bit more about logarithmic functions at some point in this semester, or we might have already. But right here, all we were just doing is putting them in the calculator, okay? You can use the log of whatever number and put it in your calculator very easily. So we've got the number of fixed payments left is negative log of 1 minus the rate divided by n times the accrued amount divided by the payment, and then all that divided by the log of 1 plus r over n. Assume you want to buy a new computer that costs $2,200 using a credit card that has an APR of 19.99%. How long will it take you to pay off the computer if you make regular monthly payments of $40? So, here is our very long formula. And we're going to plug in. The rate would be 0.01999. You're making monthly payments, so N is 12. The total amount of the loan was $2,200, and you're making payments of $40. And 1 plus the rate divided by n. Okay. So let's start talking about how to solve this by hand with the help of the calculator, of course. So we've got 0.1999 divided by 12. That is 0.016658333, and 2,200 divided by 40 is 55. And 0.1999 divided by 12 plus 1 is 1.016658333. Okay? So multiply our decimal there by 55 first and subtract that from 1, and we get 0.08379166667. And on the bottom, you can go ahead and put that in your calculator. You just find the log button. On a graphing calculator, it's the fourth button on the left from the bottom. And that would be 0.0071750,247. So find the log of the number on top and divide by the number on the bottom. Don't forget about the negative there on top. And we get 150. 150 monthly payments. To make that make a little bit more sense, that would be 12 and a half years. How much will you pay in the long run for the computer if you make these monthly payments of $40? Well, I turned the page too quick. You've got 150 payments. Of $40. That's $6,000 for that computer that you're going to end up paying. How long will it take you to pay off the computer if you make regular monthly payments of $80? We'll use the same formula with a lot of the same information, except for PMT will be 80. Now go ahead and tell you, because we've already worked this out, it'll be 37 months or 3 years and 1 month. How much would you pay in the long run for $80? So you've got 37 payments times $80, $2,960. So a lot better than if you paid $40. Fixed installment loans have a fixed interest rate and are paid off with monthly payments over a specified amount of time. A down payment is a cash payment made up front towards the total purchase price of the goods or service. The amount of a monthly payment, PMT, on a fixed installment loan is calculated with this formula. So this is on an installment loan. Before, when we were finding the payment, we were talking about savings loans and all. So this is P, that's the initial amount, principal, times the rate divided by N, all divided by 1 minus, 1 plus the rate divided by N to the negative NT. Kelly wishes to purchase a new car. The car she has chosen has a price of $34,000, including taxes and fees. She chooses to make a down payment of 20% of the price and wants to finance the remainder. If Kelly has acquired an APR of 3.99% for a 72-month loan, what is the amount of her monthly payments? So first we need to figure out what her down payment is. So it would be 20% of $34,000 or $6,800. So the principal that she's going to finance will be that $6,800 subtracted from $34,000. So she's going to finance for $27,200. And so now we'll plug into our formula of P times R over N divided by 1 minus 1 plus R over N to the negative NT. So P was that amount we just found, $27,200. The rate, 0.0399 divided by 12. 1 minus 1 plus the rate. To the negative n times t, it was 72 months. So let's see, 72 months divided by 12 months is 6 years. Okay? .0399 divided by 12 is this number. And that plus 1 is this number. Negative 12 times 6 is negative 72. So multiply on the top, we get 90.44. And on the bottom, raise to the negative 72nd power. We get 0.7874126166. So subtract that from 1 and divide, well, I've got it written down here. Let's see. On the bottom, we've got, when we subtract from 1, we get this number. And divide. So it looks like the payment each month for 6 years would be $425.43. Dean gets to choose from one of the new car incentives when he purchases his car next week. He can either choose 0.9% APR financing for 60 months or $1,500 cash back with a 3.75 APR over 48 months. Compare the two incentives that Dean has to choose from if the new car he wishes to buy is $27,465 and he's saved a payment of $5,000. So first, we need to figure out the principal that's going to be financed for option A. Oh, there's a nice graphic. And so that'll be the cost of the car minus how much he's putting down, $5,000. So he's going to finance $22,465. The payment, when we plug into our formula, $22,465 times an interest rate of 0.009 divided by 12 over 1 minus 1 plus rate divided by n to the negative n times time, and it says 60 months, that's 5 years. So his payment will be $383.04. Let's go over, before we do anything more with option A, and take a look at option B. For option B, here's the cost of the car. Subtract $5,000 that he's putting down, plus he decides to stick in the $1,500 there for his down payment too. So he's going to finance $20,965. So we use that number for P. But this time our interest rate is 0.0375. So the interest rate is a lot more this time, even though he put less, or he put more down. So his payment will be $471.03. A lot more. But, oh, wait a minute. That's the right number. But this T was supposed to be 4, I do believe, because it's for 48 months. Sorry about that. There we go. Okay, so looking at the payments each month, it looks like option A would be better. But to really compare, we need to see how much he's going to end up paying total. So the total payment would be this payment amount number times 60 for option A. And for option B, it'd be our payment times 48. So in option A, he ends up paying $22,982.40. For option B, he ends up paying $22,609.44. So overall, if he can afford the higher payment, then it's better to do option B. But only if he can afford the higher payment, of course. William and Helen are preparing to buy a new home in the Midwestern United States. They've saved $21,300 for a down payment. The total price of the house is $131,800, including taxes and fees. Find their monthly mortgage payment if the fixed interest rate is 3.52% for a 32-year loan. So, again, just like we've been doing, we need to find the principal. I'll work through this pretty quickly because it's the exact same thing we've been doing in the last problems. Subtract off the down payment. And so they're financing for $110 or $110,500. So their payment would be $1,000. Well, you get the idea. We're just going to plug in everything here into our nice little formula. And I'll probably work this one in Excel for you. And we get that their mortgage would be $497.43. Not too bad. The maximum purchase price for a house could be found with this formula. A payment times 1 minus 1 plus r over n to the negative nt divided by r over n. Again, you can see these are all just manipulations of the same formula. So example 5 says, suppose you have recently graduated from college and want to purchase a house. Your take-home pay is $3,220 per month, and you wish to stay within the recommended guidelines for mortgage amounts by only spending 1/4 of your take-home pay on a house payment. If you have $15,300 saved for a down payment, with your good credit and the down payment, you can get an APR from your bank of 3.37% compounded monthly. What's the total cost of a house you could afford with a 15-year mortgage? So first of all, we need to find your advised monthly payment. We want a quarter of your take-home pay. So we'll multiply 3220 by 0.25, and so your maximum payment would be $105. Okay? So the maximum purchase price is your payment, that's $805, times 1 minus 1 plus a rate of, 3.37, so 0.037 divided by 12 to the negative n times t is 15, over our rate divided by 12. So go through the same process that we've done on other problems. And so he could buy a house, or you, he or she, could buy a house for $113,617.82, except you have a down payment. So the actual total price would be this number we found, plus your down payment of $15,300. So he could be looking for, or you could be looking for, a house for $128,917.82. Okay? That's if you wanted a 15-year mortgage. What if you want to do a 30-year mortgage instead? In that case, we would change the 15 to 30. Okay? And that comes up with $182,201.11. Add that to the down payment, and we get that you can buy a house for almost $200,000 if you want to pay on it for 30 years. Good financial habits: make a budget, control impulse spending, have an emergency fund, be a smart consumer, monitor your accounts and pay your bills on time, and ask questions anytime you have them. That concludes our little chapter on finances. Take a look at some of these examples. For example 1, we're trying to find the number of regular monthly payments are. When we've got an amount we're financing of $2,200, a regular payment of $40 for Part A anyway, a rate of 19.99%, and N is 12. So, for our formula, the big deal is to make sure that you get in enough parentheses. So the whole top needs to be in parentheses. Oh, forgot my equals. And then negative, log, and then everything in the log needs to be in parentheses. So 1 minus R divided by N, in parentheses, times A divided by the payment, in parentheses. And then we'll close the log parentheses and close the top parentheses. Divided by everything on bottom, which was log of, everything in log needs to be in parentheses, so 1 plus, and then the rate divided by N needs to be in parentheses also. Close, close, close everything on the bottom. And cross your fingers, got it. 150 monthly payments. Now this problem in part C asked us to find out how many payments if the payment was $80. So all we'd have to do is go up here and change this 40 to an 80, and there we got our new number. Next, let's look at example 4, where we were trying to find the payment with an amount financed of $110,500, a rate of 3.52%. N was 12, and for 30 years. So equals, everything on top needs to be in parentheses. So P times, and then R divided by N in parentheses, close the top, divided by, everything on the bottom needs to be in parentheses. So 1 minus, then the 1 plus R over N needs to be in parentheses. 1 plus R over N needs to be in parentheses. Then close the 1 plus R over N and raise that to negative N times T in parentheses. And close the bottom. And there we have the monthly payment. And then last, for example 5, we're trying to find the maximum purchase price for a payment of $805 with a rate of 3.37%. And was 12 for 15 years for part A, and then we'll find for 30 years for part B. So the maximum purchase price using our formula would be equals our payment times, then all the top needs to be in parentheses, 1 minus, 1 plus R over N needs to be in parentheses, 1 plus R over N needs to be in parentheses. So close the 1 plus R over N, raise it to the negative N times T in parentheses. And close the top. Then we'll divide that by the bottom, which is just R divided by N in parentheses. And then you can see there was the amount before the down payment that he could or you could afford. And if we want to change to a 30-year mortgage, all we got to do is change the T to 30. There we go. Okay, one more section on finance. So here's your 4 extra examples. Suppose you want to purchase a house. Your take-home pay is $4,270 per month, and you wish to stay within the recommended guidelines for mortgage amounts by spending only 1/4 of your take-home pay on house payment. You have $18,500 saved for a down payment, and you can get an APR from your bank of 5.7% compounded monthly. What is the total cost of a house you could afford with a 30-year mortgage? Okay, so the fact that they have a down payment is great, but we don't need to worry about that until the end. We're going to use the formula for maximum purchase price. I think that's fairly obvious with this because we're trying to find the maximum purchase price. So that formula says, I'm just going to abbreviate maximum purchase price. And it is whatever your payment is going to be times. On the top, we have 1 minus 1 plus R over N, looking familiar, to the negative NT. Close our bracket. And on the bottom, R over N. You kind of see that these are all kind of the same formula rearranged, just solving for something different. Excuse me. Okay, so the first thing we need to figure out is what is our payment going to be? So the take-home pay is $4,270 per month, and we want to be 1/4 of that to be the payment. So our payment, use a different color here. Will be 1/4 of 4,270, and that is $1,067.50. So that goes in this spot here. And then we have R, that's the 5.7%, change it to a decimal, 0.057. We're compounded monthly, it says, so N is 12. And T, it says for a 30-year mortgage, so T is 30. Put R over N on the bottom again. And again, I'll go over to Desmos and do this, but you end up with $183,924.74. So that's a pretty good amount for a house. And you would want to stop here, but don't. Because don't forget that we had this down payment here. Okay? So that means that they have an additional $18,500 to put on this home. So our actual maximum purchase price would be $18,500 plus what we just found, $183,924.74. And so it comes up to be, oh, my computer just turned off, where I had my numbers, $202,424.74 is how much you could afford to pay for your house. Example 2 says, consider a credit card with a balance of $8,000 and an APR of 12.5%. If you want to make monthly payments in order to pay off the balance in 3 years, what is the total amount you'll pay? Well, you're going to use the formula that says, I think it's actually labeled to pay off a credit card. Okay? So that's the formula you're going to use. It is, you want to find your payment. You've got your principal, your initial amount, times R over N. And that is divided by 1 minus 1 plus R over N to the negative NT. So your principal is $8,000. Go ahead and write some of this. Your rate, 12.5%. That's actually not too bad for a credit card. So 0.125 for R. And you're making monthly payments. So N is 12. And it says we want to pay it off within 3 years. So T is 3. So again, we'll do that in Desmos, and you end up that your payment needs to be $267.63 each month. Now notice our question was not just what will the monthly payment be? It was what is the total amount you will pay? So to find the total amount you'll pay, you'll take that $267.63 and multiply it by 3 years. So 12, changing colors here, 12 months for 3 years. And the total amount you would pay is $9,634.68. So you can see you're paying over $1,600 just in interest on that credit card. Yuck. Example 3 says, Will bought a new car and financed $18,000 to make his purchase. He financed the car for 48 months with an APR of 4.5%. Assuming he made monthly payments, determine the total interest Will paid over the life of the loan. So yes, we're going to figure out the interest that he paid. And to do that, we're going to have to figure out how much he paid total. But to figure out how much he paid total, we have to first figure out what was his payment. So we're going to use that same formula that we used above. The principal is $18,000. And the interest rate is 4.5%, so 0.045. We're making monthly payments, so N is 12. And it says for 48 months, though that's 4 years, but what we can actually do here is 12 times 4 is 48. So 48 months is actually what goes in the NT spot. And we get that the payment would be $410.46 each month. Okay, so we need to figure out what he's paying total for this loan. Well, that would be the $410.46 times 48 months, or 12 times 4. And so total, Will is paying $19,702.08. And last, again, we're trying to figure out the interest. So if he's paying this $19,000 total, we can subtract off the amount he financed, and that will tell us how much interest is left. So he paid $1,702.08 in interest. And our last problem here says a new school building was recently built in the area. The entire cost of the project was $26 million. The city has put the project on a 30-year loan with an APR 2.9%. There are 19,000 families that will be responsible for making monthly payments towards the loan. Determine the total amount that each family should be required to pay each, that should say year, to cover the cost of the new school building. Okay, so if we need to find out how much is going to be paid each year, then we're looking for a payment again. So we're using that same formula. So the principal amount was $26 million. Leave a little more space there. Okay, and the interest rate, 2.9%, so that's 0.029. They're going to make monthly payments, so N is 12. And it says for a 30-year loan, so T is 30. Comes out that our payment is $108,219.79. That's the monthly payment. That's a lot. Now, this is not our answer because it says find the total amount that each family should be required to pay. So, hopefully each family isn't going to be paying this. So this is our total monthly payment. So we can figure out our, let's call it the payment for each family here. And this is the monthly payment for each family. Just by taking this total monthly payment and dividing by, it says there are 19,000 families. So each family per month is only going to pay $5.70. Well, we're still not done, okay? Be careful that you're reading your problem carefully. It says, how much should they pay each? Again, that's supposed to be year. So to find the yearly amount each family is going to pay, then we'll need to take our $5.70 per month and multiply it by 12 months. So each family would need to pay $68.40 each year. Okay? So as I said, I'll go over into Desmos and work at least one of these. They all use the same formula, so I may not need to work more than one. But you get the idea, hopefully, what to do with these homework problems now. Just going to work one of these problems. There's no sense in working all 4 of them when they use the same formula. So we're just going to do number 4 here. So we've got on the top, we need to take 0.029 and divide by 12. And then we need to multiply that number by 26 million. Double click, copy, paste. There we go. There's the number on the top. Okay, and then on the bottom, we're starting with our 0.029 divided by 12. So I'm going to copy that again. And we want to add it to 1. So 1 plus paste. And I need to do negative 12 times 30, in case we don't know what that is. And then we take what's in the parentheses, which was this 1 plus 0.002, blah, 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 and raise it to the negative 360. Okay. And then once that is done, we subtract from 1. So 1 minus, copy, paste. And last, we take the number on the top. So we got to go back and find it. Be careful you keep everything here and know where to look. So copy, and we'll paste that down here, and we're dividing by this number. And here we get our payment of $108,219.79. Then I can go ahead and use that to divide by 19,000. And last, we do want to go ahead and round here because each family is paying exactly $570 a month, not 5.69577, all that, okay? So we want to round 5.70 and then multiply that by 12. So here we have our $68.40 per year. Oh, then there is Willow saying hi or bye. Hopefully this helps.